Good day. In this video we're going to solve these equations and a few more. All the equations have a variable in the air, so we have an unknown exponent that we have to solve. Later in life you will use logs to solve it, but now we're not allowed to do that. We will show you a method how you can solve them. In all the equations we have to solve for x. Let's do the first two. The first one says 2 to the power of x equals 8. We have to solve for x. We prime factorize the 8, it becomes 2 to the power of 3. And now because the bases are the same and we have an equation, we can drop the bases. Final answer, x equals to 3. The next equation looks like this. Because we have a divide over here and our bases are the same, we will minus the exponents. So you write down the base once and you minus the exponents from each other. This 1, I also want it to become a 2. I need my bases to be the same. So we write the 1 as 2 to the power of 0. Now the bases are the same. The 2x minus x gives me x. So x minus 1 equals to 0. Plus 1 on both sides, we get x equals to 1. Remember, you should check your answer with a calculator. You take this 1, you substitute it back in there, and see if the left-hand side equals the right-hand side. The next equation looks like this. We have to solve for x. Convert this to exponents. Keep the left-hand side. The square root of 3 can be written as 3 to the power of a half. And that 3 has an exponent as 1. Because the bases are the same and I'm dividing, I will minus the exponents. That'll give me 3 to the power of a half minus 1. Then the right hand becomes 3 to the power of minus a half. Then we have 3 to the power of x plus 1 equals 3 to the power of minus a half. Because my bases are the same, I can drop them. We write x plus 1 equals minus a half. We minus 1 on both sides and we get x equals to minus 1.5. Please stop the video and get your head around this one. The next equation looks like this. We have to solve for x. This 9 we change to 3 squared. The cube root becomes to the power of a third. Here the square root of 3, I make it 3 to the power of a half. Keep the 2x as an exponent. We times the 2 and the third, we get 2/3 in the air. We times the half and the 2x, we get an x in the air as exponents. Because the bases are the same, I may drop the 3's. Final answer, x equals to 2 over 3, or 2/3. The next equation looks like this. We have to solve for x. We change the third to exponential way of writing 3 to the power of minus 1. Times that 1 with that x and that 1 with that minus 1. Then it looks like this. This 1 over 27 becomes 3 to the power of minus 3. 27 is 3 cubed and then becomes 3 to the minus 3. Because these two bases are the same and I'm multiplying, I add the exponents. So we get 3 to the power of x minus 2 equals 3 to the power of minus 3. Because the bases are the same, we can drop the bases. X minus 2 equals to minus 3. Plus 2 on both sides, so x equals to minus 1. Please stop the video and get your head around this one. Try and keep your wits together on the next one. We have to solve for x. 0.375 we can write as 375 over 1,000. If you simplify that, it will become 3/8. A possible way from here on is to prime factorize all the big numbers. We keep the 3. The 8 becomes 2 cubed. The 9 becomes a 3 squared. And the 64 becomes 2 to the power of 6. Now we can see that this and this looks related. So I need the base to look the same on this side. Going backwards on exponent law 3, you can take out a power of 2. Then this will be the same as this. And then this and this looks the same. Because this base and this base are the same, we may drop the bases, then x equals to 2. Please stop the video and get your brain around this one. The next equation looks like this, and we have to solve for x. The first thing we can do is to take this to this side. The 8 becomes 2 to the power of 3, so that becomes 2 to the power of minus 3x. If you times that 3 with that minus x, that 2 weights. That 4 we can make it 2 to the power of 2, or 2 squared. We can multiply that 2 with that x and that minus 1. So this is what the equation looks like now. Because we are multiplying and the bases are the same, we add the exponents. We get 2 to the power of minus 3x equals 2 to the power of 2x minus 1. That 1 minus 2 is minus 1. Because the bases are the same, I may drop the bases. then we have minus 3x equals to 2x minus 1. We minus 2x on both sides to get the x's to one side, and we get minus 5x equals to minus 1. And then we divide by minus 5 on both sides. Then we get x equals to 1/5. Please stop the video and get your brain around this one. Here we also have to solve for x. Because we don't have any laws for exponents adding and subtracting, we have to find another way to solve this problem. We can write down 3 to the power of x, then we ask 3 to the power of x times what will give us 3 to the power of x, which is 1. Then we ask 3 to the power of x times what will give me 3 to the power of x again, which is times 1 again. And 3 to the power of x times what will give me 3 to the power of x again, which is 1 again. Think backwards. This times this will give me that, this times this will give me that, and this times this will give me that. That gives us 3 times 3 to the power of x is this. Because we are timesing and the bases are the same, we add the exponents, we take that 1 plus x and we write it. So now our bases are the same. So we drop the bases, 1 plus x equals 3x. Minus x on both sides, then you get 1 equals to 2x. Divide by 2 on both sides to get rid of this 2, and we get a half equals x. The value of x is a half. Some people understand that this 3x plus 3x plus 3x is 3 of them. Like we could always have a k plus a k plus a k would give us 3 k's. The same way we can say this plus this plus this is 3 times this. If you can get your head around that, and then we just go down the same way. Please stop the video and get your brain around this. The next equation looks like this. We have to solve for x. We change the 1 to 3 to the power of 0. Because the bases are the same, I may drop the bases. We get x squared minus 4 equals to 0. Plus 4 on both sides to get the x alone. To get rid of the square, we square root both sides. And remember to write x equals to plus or minus the square root of 4. Final answer, x equals to minus 2 or x equals to plus 2. The next equation looks like this. We have to solve for x. We prime factorize the 27, so that becomes 3 cubed. Times the 3 with the x squared and the 3 with the x, and we end up with this. Here we prime factorize the 9, that becomes 3 squared. Because we are multiplying here, and the bases are the same, we write down the base once, and we add the exponents. Now, because the bases are the same, I may drop the bases. Then the equation will look like this. Now we have to solve for x. We minus 3x squared on both sides. Then we have 3x equals to 2. Divide by 3 on both sides, we get x equals to 2 over 3, or 2/3. Please stop the video and get your brain around this one. Let's look at the last two equations. It still says solve for x. If you see a situation like this with plus and minuses, and that exponent is twice as big as that one, we will factorize this. We will take this, and here we will write 3 to the power of x and 3 to the power of x. Because 3 to the power of x times 3 to the power of x will give us 3 to the power of 2x. Almost like this becomes k squared, k, and no k. Please look at the video that says solve equations without using k. So like we said, we'll have 3 to the power of x over here and 3 to the power of x over here. To get 27, we write 3 times 9 because we want to get back to 6. Because there's a minus here, we need our signs to be different. Because there's a plus, the biggest number will get the plus. So we put the plus there and the minus there. Now we'll get 2 answers coming out of here. Get 3 to the power of x equals to 3. That comes out of here. And 3 to the power of x plus 9 becomes 3 to the power of x equals to minus 9. Because these two bases are the same, I can just write x equals to 1. On this side, we'll write no solution. If we have a power with a positive over there, the answer can't be a negative. Please stop the video and get your head around this. Remember to look at the video that says solving equations without the k method. Right, the last question is a bonus question. It still says solve for x. In this case, it's impossible to get the bases to be the same. So what we can do is we can keep the left-hand side, and on the right-hand side, we can take a common 2 out of that exponent like this. That then gives us 4 to the power of x minus 3 equals 9 to the power of x minus 3. Now we can see that the exponents look the same. The only way we can have a 4 to the power of something equal to 9 to the power of something if the something is equal to 0. Because 4 to the power of 0 is 1, and 9 to the power of 0 is 1. And that means then they are equal. Let me just say, this x minus 3 is equal to 0. And we plus 3 on both sides, so we get x equals to 3. If you take that 3 and you substitute it back in there, you're going to get 4 to the power of 3 minus 3, which is 4 to the power of 0. Take that 3, substitute it back in there. 2 times 3 is 6, minus 6 is 0. That gives you 4 to the power of 0 equals 3 to the power of 0, and that will be true. You may send a message to this number if you want to arrange an online lesson in mathematics. Please indicate whether you liked or disliked the video and subscribe to the channel. Enjoy exponents.